I'm Carl Peterson, an energy educator with North Dakota State University Extension Service. And today we're in the greenhouse facility, the greenhouse research complex on campus that we're building and in the process of adding on to. And we're going to talk about and point out some of the innovative energy aspects that are going into the facility. We're going to point out how innovative the controls are, how we can heat and cool this building, and also the different lighting and electronic aspects of it. The greenhouse is being constructed in three main phases. The first phase is already complete, and we already have research going on in those greenhouse as we speak now. The second phase is under construction just to the south of us, and then the third phase will hopefully be completed here in the near future. Here in the head house, there's a couple of interesting things that we can point out just being here. The lighting in this hallway here is automatically controlled. The more light that comes in, natural sunlight, the more lights turn off. As it gets darker on into the evening or cloudier days, these lights will automatically turn on and light this hallway. Another example of using energy efficiently in this building is when we walk into a room, they're on motion detectors, so the lights automatically turn on. As we're in the room, we're working, the motion detectors on the wall will detect that, and then as we leave, we don't turn off the lights will automatically shut off on themselves once we leave the room. And the other thing is this building is balanced. If the lights in a certain part of the building are creating heat, then we can pull that heat off and run it to a different part of the building that might need a little bit more supplemental heat. So we can balance the building within itself. One of the efficient things that we have in this greenhouse complex is the sunshades. We open them up, they're automatically open in the daytime, and they'll allow that heat and light to come in. And then in the evening, we want to keep that heat inside the building, so they'll automatically close in the evenings and retain that heat inside of the greenhouse building. And you can see those shades starting to close now. The innovations in lighting also in this building are saving a lot of energy resources. If we look at the control panel here, these lights in each one of these rooms are controlled separately depending on what the researcher will need. There's a weather station outside that detects the amount of sunlight we have coming down, and when it detects the amount of sunlight they need, they'll shut off the lights inside of each one of these rooms. If they need more light in there, they'll automatically turn on. The other thing is too, the actual light itself is more efficient than the traditional greenhouse light bulb. These light bulbs draw 600 watts of power when they're on versus 1,000 watts in a traditional light bulb. So each one of these lights is over 400 watts more efficient. The other thing about these lighting systems in here is the reflectors, the deflectors that are built into it were designed specifically to aim that light directly at the plants and the benches that are growing in these rooms. So we don't have any light going throughout the room, it's going directly where we want it.
This is a cutting-edge technology building when it comes to HVAC. I mean, typically we don't get a lot of notoriety for what we do here, but this is probably one of the most energy-efficient mechanical systems you're going to see. What we do is transfer the energy through this, what we call a heat pump, a water-to-water heat pump. We transfer the energy from this building during the summertime. We are trying to reject the heat out of the building, so we put the energy into the well field, and then we pipe it out approximately about 500-600 feet away into the ground. The ground then absorbs that energy. Then during the wintertime, we pull that energy back out, goes back into this system here, to this heat pump, and that's how we then extract that energy to heat the building in the wintertime. This is where that efficiency system comes in with the water-to-water heat pump. It's 30% more efficient than the traditional heating system that they had in this facility. The VAV system that we have here, it's a variable air volume system where we can actually reduce the airflow into each one of these rooms, thus cutting down horsepower being used to move the air, along with the heat pump system that we have here. I mean, those two in conjunction make this thing even much more energy efficient than a typical standalone heat pump system. I mean, we monitor the temperature in every room, the airflow in every room, the water temperatures leaving this unit, and we have that full ability to sit behind the computer, and I can turn on a pump, change this thing shut. I can do anything just from a click of my mouse.
One of the things that was important to us as we put this together was trying to learn about energy efficiency and wise use of natural resources and in particular energy. So as we began to work with the designers, the architects and engineers who put this together, one of the values we talked about was putting in ways to economize in the use of energy, to recover energy, and what has been designed into this facility is a whole set of systems to be as energy efficient as possible. Part of what we're doing also will be monitoring these systems and learning from them, and be working very closely with the folks that have helped design it to to tweak them to make them work as well as possible, but also to continue to learn so that as we do additional phases of this, we'll do them better and hopefully share information with folks throughout the area. There will be more capability under one roof in this facility than there is anywhere else in North America. And it allows our scientists to do experiments more precisely, they get better answers and they get them more quickly.